Hello and welcome to Ground Control HQ, where today we're talking about all things data logging. My name is Fenemor, I'm a Client Solutions Manager here at the company, and today we're showcasing the RockBLOCK RTU. Let's get into it. Picture your weather station, forestry operation, reservoir or borehole, lying just beyond or on the edge of cellular connectivity, with no or limited power supply. You might have a remote data logging challenge on your hands. A typical telemetry outstation could be overkill if you just want to, for example, monitor fluid levels on an hourly basis and alert at any sign of an abnormal reading. RockBLOCK RTU provides a low-cost, easy-to-deploy micro data logger powered by solar or battery pack. It still provides data, alerts, control, and historical data recording, but it's more cost-effective and draws less power than other satellite alternatives. Let's look at the device in more detail. The RockBLOCK RTU functions as a micrologger and switch controller with edge buffering and processing capability. It does these three jobs nested within a tough IP68 rated shell with two dry contact digital inputs, one configurable analog channel, and one open drain output. It also includes a configurable serial interface for sensors working with protocols such as NMEA, DNP3, and MODBUS. RockBLOCK RTU accepts any industry standard 4 to 20 mA sensor as well. With RockBLOCK RTU, you have more than one option for data transfer. You can use dual mode Cellular and Iridium for more real-time critical applications, or the emerging standards-based NTN services for more infrequent logs and potential battery saving. Iridium uses a mesh of low Earth orbit satellites. That means lower latency, around 10 seconds or so, and coverage anywhere on the planet, including the poles, oceans, and mountain ranges. SBD is built for small, efficient data transfers, making it ideal for transmitting sensor readings, status alerts, or control signals without the power and cost overhead of larger systems. Paired with dual-mode cellular LTE, it's proven ideal for rugged, off-grid, real-time telemetry where immediacy and reliability matter most. Choose this satellite connectivity option for time-sensitive monitoring and decades of field-proven deployments. Now to the standards-based NTN connectivity option. NTN enables data transmission over satellite using the same standard as terrestrial NB-IoT. The benefits of this are, firstly, if you're working with a mobile application, your device can switch from cellular to satellite connectivity with limited engineering work required. Secondly, once the service matures, you should also be able to switch airtime provider, avoiding vendor lock-in. Finally, because the data packets are tiny and sent periodically rather than on demand, it's anticipated that it will draw very little power. If your application has very small data volumes, under 30 kilobytes per month for example, and can manage with 2 to 4 transmissions per day, this may well be worth exploring for you. Whatever connectivity option you choose, your data is logged to the cloud and visible within Cloudloop, our IoT management platform. Cloudloop data decodes raw payloads and turns them into structured formats that you can route directly into your systems. Instead of writing your own code to decipher device messages, Cloudloop data handles the translation and delivers the data to your chosen destination, whether that's MQTT, HTTPS, AWS, Azure, or another variety. It's designed to get your data where it needs to go in the format that you really need. For customers who prefer to use their own platforms or IoT systems, Cloudloop offers full API access, complete with a developer site and code examples, so you can access your data wherever it works best for you. While Cloudloop data handles the delivery of raw sensor data, Data Insights takes it further, turning that data into something you can actually work with. It translates values like voltage, humidity, temperature, or flow rate into readable, visual channels, all displayed in a single dashboard. We have a quick live demo of this here, using my well-placed cup of coffee. The PT100 sensor is connected through a 0 to 10 volt transmitter into channel 3 of the RTU. As you can see, temperature readings are being sent to Cloudloop at 30-second intervals. We have configured the RTU to send an alert if the upper limit exceeds 70 degrees centigrade. A warning perhaps that the coffee is too hot to drink, which I'm pretty sure it would be. Once I place the sensor inside the coffee, we should expect to see the increase in temperature and the alert outside analog trip to appear within the next 30 seconds or so. While we're waiting, it's worth noting that low trip levels can also be set. So if I wanted to be alerted that the coffee was too cold, that'd be possible too. Also, since we're inside, I have set the RTU to use cellular rather than Iridium data services. And there we are, the alert has now come through. I'll need to leave that to cool a little longer. Not much of a real-world application, but if you needed an alert if a piece of remote equipment overheats, then this is the function for you. You don't have to have the 30-second monitoring. You can save data and just get a value every 24 hours. But if that temperature soars, then the alert will come through almost immediately to your email inbox or via SMS. Whether you're monitoring one RTU or a network, you can view multiple data streams in real time as channels, create alerts for anomalies, or exceed parameters and track performance over time. So why choose the RockBLOCK RTU? With a choice of satellite and cellular connectivity options, it solves the remote data logging challenge, providing a reliable, flexible remote logger without the complexity or cost of traditional systems or manual data collection. If this has sparked your interest or you're getting ready to deploy, contact our team for more information about our device and connectivity options. We'd love to help you.